Welcome to this explainer. Okay, so have you ever looked at a perfectly assembled car, or maybe one of those tiny, super intricate microchips, and just wondered how on earth did they put this together so flawlessly? Well, today we are going to figure that out together. We're diving headfirst into the incredible world of industrial assembly robots, taking it from the absolute basics all the way to advanced professional career opportunities. If you're curious about the hidden magic powering modern manufacturing, you are absolutely in the right place. Let's get into it. Here is our game plan for today. We'll hit the basics of assembly robots, look at their anatomy and working principles, and then dive into industry applications and benefits. After that, we'll cover the challenges and future trends, and wrap it all up with automation, careers, and solutions. Before we get too deep into the technical weeds, think about this for a second. Will future manufacturing end up being 100% robotic? And how exactly do machines manage to assemble something as massive and complex as a car, piece by piece with flawless, millimeter-level precision? These are pretty much the ultimate manufacturing questions of our era. And as we go through this explainer, we're going to unpack the exact solutions to those very questions.
All right, let's start building our foundation with Section 1, Basics of Assembly Robots.
So let's contrast the old with the new. Traditional manual assembly relies entirely on human effort, right? And that means it's bound by human limits. We're talking fatigue, varying speeds, and that inevitable moment of, dropping a tiny essential screw and spending 10 minutes looking for it under your workbench. Robotic assembly? It changes the game entirely. The process becomes fully automated, delivering incredible precision and nonstop consistency. It's basically the difference between building a wooden cabinet by hand over a long weekend versus firing up a machine that can flawlessly build 1,000 of those exact same cabinets before you've even had your morning coffee. And hey, there isn't just one generic robot doing all this heavy lifting. They are actually highly specialized. Articulated in 6-axis robots, act a lot like human arms with multiple joints. They're perfect for heavy lifting and complex welding. SCARA and Cartesian robots move along rigid planes and tracks, making them fantastic for fast lateral movements. Think precisely snapping pieces of a smartphone together. Then you have Delta robots. These look kind of like highly caffeinated mechanical spiders, dropping down from overhead frames to pick and place lightweight items in an absolute blur. And finally, collaborative robots, or Cobots. These are designed as friendly, safe coworkers that can operate right next to us humans without needing heavy safety cages. Moving on from the types of robots, let's actually look under the hood with Section 2, Anatomy and Working Principles. A robot is literally a well-coordinated symphony of engineering. You've got the physical structure, sure, the sturdy base, the articulated arm, and the grippers using pneumatics or vacuums to act as hands. But the real magic? That's the intelligence. The PLC, or Programmable Logic Controller, is essentially the brain calling the shots. Then you have the HMI, or Human-Machine Interface. That's the actual touchscreen or dashboard an operator uses to talk to the robot. For the big picture, there's SCADA, Supervisory Control and Data Acquisition, which monitors the entire factory floor all at once. Combined with advanced vision systems acting as the eyes and incredibly precise servo motors driving the movement, well, it is a perfectly closed-loop system of continuous action. Let's actually watch this play out in a real-world microstory. Just imagine a single product moving down the line. First, step 1, a basic sensor detects it on the conveyor. Instantly, the PLC brain sends a signal to the main robot controller. Then, the robot swoops in to pick up the part while the vision cameras verify its exact position in real time to ensure absolute perfection. Next, it flawlessly assembles the component. Quality is automatically inspected by another set of sensors, and boom, the finished product moves on to the next station. This whole intricate sequence, it happens in the blink of an eye, thousands upon thousands of times a day. Knowing how they work, let's zoom out a bit. Section 3. Industry Applications and Benefits. The scope of robotics today is sweeping across almost every major sector you can imagine. In the automobile and EV battery sectors, they're handling heavy welding, painting, and complex chassis assembly. Over in electronics, they perform practically surgery-level work, placing microscopic chips onto printed circuit boards. And in pharmaceuticals and food, they operate in highly sterile environments, safely mixing, processing, and packaging the things we consume every single day. I mean, from the heaviest, most dangerous tasks to the absolute most delicate, robots are the true backbone of modern production. So why the massive shift toward this kind of automation? Well, because robots directly solve our human limitations. They offer 24/7 continuous operation, which just skyrockets productivity. Their precision slashes human error to near zero, giving you incredibly consistent quality. And crucially, they take over the dangerous back-breaking tasks, like lifting heavy engine blocks or working near noxious fumes. it keeps workers safe. Ultimately, all of this drives down long-term production costs and improves energy efficiency. And that translates into more abundant and affordable products for all of us. But of course, progress never comes without a few bumps in the road. Let's transition to Section 4, Challenges and Future Trends. Adopting robotics definitely comes with some very real, massive hurdles for companies. First off, the initial capital cost to purchase and install these systems is sky high. On top of that, their programming and ongoing maintenance are incredibly complex. Plus, integrating proper safety systems around these fast-moving machines is both critical and difficult. But, there's a really fascinating irony here. This massive push to automate away manual labor actually creates a desperate, constant demand for highly skilled human operators, programmers, and engineers to run and safeguard these very systems. And the industry definitely isn't standing still. We are rocketing toward what is known as Industry 5.0. We're already seeing the rise of AI-powered cobots that can actually learn from their environments and adapt on the fly. Engineers are increasingly using digital twins, which are entirely virtual replicas of a physical factory floor to test ideas and changes safely in the digital world before turning a single physical wrench. Powered by the Industrial Internet of Things, or IIoT, machines are talking to each other, optimizing themselves, and paving the way for truly autonomous manufacturing. Factories are literally transforming from simply being mechanized tools into highly intelligent, self-regulating ecosystems. Which leads us perfectly into our final segment today, Section 5, Automation Careers and Solutions. Remember those complex challenges we just looked at? Well, they translate directly into massive career opportunities for you. Because these smart factories are becoming so advanced, there is an incredible, future-proof demand for PLC and robot programmers. Companies desperately need robotics and automation engineers to design the lines, not to mention SCADA, maintenance, and specialized machine vision engineers to keep them running perfectly. Diving into these technologies right now, really learning how to command the machines, is practically a guaranteed blueprint for a highly successful and lucrative career. To thrive in that rapidly approaching future, you need the right knowledge and, honestly, the right partners. A prime example of a team driving this industry forward is DEVI Automation Solutions. They offer incredible professional expertise in industrial automation, PLC programming, SCADA systems, AI integration, and even smart agriculture. So if you're a business looking to integrate these smart technologies, or a professional wanting to learn more about industry solutions, I highly encourage you to reach out to them at deviautomationsolutions@gmail.com. And be sure to like, comment, share, and subscribe to their channel to stay updated on powerful solutions for a better tomorrow. As we wrap up today's explainer, I want to leave you with a provocative question to chew on. How will you prepare yourself to thrive in the era of Industry 5.0 and AI-driven automation? The robots are already here, the smart factories are being built, and the careers are just waiting for those ready to step up. I really hope this journey into the incredible world of assembly robots sparked your curiosity and empowered you to take that next step. Thanks so much for exploring with me today.